All right. And as per usual, my glasses are on my head. Okay, so we're dealing with circular motion and we're dealing with Newton's law of gravity. So what we're going to do is we're going to look at a problem here where I have an object that's a circle. And we're told that my object is 12 inches in diameter. And we're told that we have a bug on the rim of our object. And we're told that the disk is going to accelerate from 0 revolutions per minute to 76.0 revolutions per minute over a time period of 4.4 seconds. And what we want to know is we want to know the tangential acceleration. We want to know the magnitude of the tangential velocity at the end of the acceleration. We want to know 1 second, at 1 second, what the tangential velocity is. And we want to know at 1 second the centripetal acceleration. Now, the centripetal acceleration is our center-seeking acceleration.
I'll go. Our regular.
Yeah, don't you have to order it on the app to get the T4?
No, you don't.
That's the center-seeking acceleration. All right, and then finally, the last one is we want to know 1 second, what's the total acceleration? And this is going to be our acceleration tangential and our acceleration centripetal. So the first thing we're going to have to find is the magnitude of our acceleration, all right? And our acceleration tangential, so if we're looking at our circle, anything tangential is going to be coming off of our circle at any given time. So if I'm over here, it's going to be here. If I'm over here, it's going to be here. If I'm over here, it's going to be here. Think of it this way, that if I'm swinging an object around, like in one of the videos that I have, that I'm swinging the object like I am David of David and Goliath, that if this rope breaks, the ball is going to go off in that direction, and that's our tangential direction. So this problem is going to allow us to look through a lot of our rotational motion items. So my acceleration tangential, this is going to be where I'm correlating back with my linear motion, where I'm having r as my radius, and that is times my angular acceleration. And then my angular acceleration is equal to my angular velocity final minus my angular velocity initial divided by my change in time. So we got a few things that we got to worry about here. All right, we got a few things I worry about. Now I made a mistake. This says my 12 inches in diameter. And if I have a 12 inches in diameter, that means I'm going to have 6 inches in radius. The other issue I have is the speed, revolutions per minute, is a velocity. But we want this in, we're going to want this in meters per second. We're also going to want this in meters. So we've got to do some unit conversions. So let's do our unit conversions first. So 6 inches. And this is how I would do it because it's how I remember things. There's 2.54 centimeters per 1 inch. And there are 100 centimeters in 1 meter. So I can do that conversion. And I'm going to get 0.1524 meters. Now, if I do revolutions per minute, I'm going to have 76.0 revolutions per minute. And I've got to convert that. And remember, this is where I'm going to convert. There's going to be 2 pi radians per 1 revolution. So that's my conversion factor that I have to worry with here. 2 pi radians per 1 revolution. And then I got to get rid of my minutes, and I'm going to have 1 minute is equal to 60 seconds. So I'm going to be able to convert that. So 76 times 2 times pi divided by 60 is going to give me 7.959. And this is now in radians per second. So now I can go up here and I can start plugging in my numbers. I've got my 0.1524 meters. I'm going to have my 7.959 radians per second minus 0 radians per second divided by my change in time, which gave me 4.4 seconds. And if I do that, I end up with 0.276 meters per second. So this gives me my tangential acceleration where we're at for this particular part of the problem. We also want to know the tangential, the final tangential speed. So that's my velocity is going to equal r omega final. We've already converted our 6 inches. And our 6 inches is now 0.1524 meters. We've already figured out our final radians per second. So we've got that one. And that's our 7.959 radians per second. And if I do that number, I get 0.1524 times 7.959. And I get 1.21 meters per second. Now, if we want to know at 1 second, okay. So the next question is, we want to know the part of the problem tells us that, yeah, we want to know at 1 second, what is the magnitude of the tangential acceleration. Now, this is kind of one of those questions of, you got to remember what the problem said, and what we're doing is we are traveling at a constant acceleration. So we're traveling at a constant acceleration. So that means if we're traveling at a constant acceleration, our AT is going to be our angle there. And that doesn't matter where we're at. And so what that one is going to go back to our 0.276 meters per second squared, which we figured out early on. And I will fix this on my notes because I forgot to square my second squared on my notes. So now you've got that second squared fixed in the notes. So that part C is just realizing that we have to be at a constant. So then at 1 second, we want to know what our final velocity is. Well, our tangential velocity is going to equal our initial velocity plus our acceleration tangential times time. We started at rest, so that's 0. And so this is 0.276 meters per second squared times 1 second. And this gives me 0.276 meters per second. So that's our tangential velocity. Now our centripetal is going to equal our tangential squared divided by our radius. So now we're going to put our 0.276 meters per second. We're going to square that divided by our radius, which is in meters. And we figured that out as 0.1524 meters. And so now we can do that one. And if I plug all of that in, 0.276, we're going to square that, divide it by 0.1524, and I end up with 0.499 meters per second squared. And then finally, our acceleration is going to equal the square root of our centripetal acceleration squared plus our tangential acceleration squared. So that's the square root of my 0.276 squared plus 0.499 squared. And then I take the square root of all of that. And I get 0.570 meters per second squared. And my angle is going to be the arctangent of my tangential divided by my centripetal. And that's going to be the arctangent of my 0.276 divided by my 0.499. And if I plug that into my calculator, I end up with 28.9 degrees. So that's a really good problem to look at to kind of review everything that we're dealing with in our converting back and forth between our linear components and our angular components. It's a good problem to look at how things change as we're doing a constant acceleration. So this is a really nice problem to kind of walk through the concepts that we had in chapter 7. Questions?